Hey, this is Workbench Quagmire, back again with our free code camp Python certification in 100-ish days, and it is day 80. Today we have another lab that we'll be going through. So this one's called Implement the Luhn Algorithm. And so the Luhn algorithm is also known as the modulus 10 or mod 10 algorithm. It's a simple checksum formula used to validate a variety of identification numbers like credit card numbers. These are steps to validate a number using the Luhn algorithm, or Luhn, however you pronounce it. Starting from the right and excluding the rightmost digit, the check digit, double the value of every other digit. If the result of doubling a digit is greater than 9, sum the digits to get a single digit. Alternatively, you can subtract 9 from the result. It's true. Take the sum of all the digits, including the check digit. And if the sum of all the digits is a multiple of 10, then the number is valid. Else, it is not valid. So let's say we have a number 453914881. The steps to validate the Luhn algorithm would be so we're doubling each of these, and then we're doing this. So we don't do anything with the last one. We double, subtract 9 or add the digits, you get 7, 8. It's every other one, so it's 8, 8, 8, 4, 8, 8, 1, 1, 1, 9, 18, 9, 3, 3, 3, 5, 4, 10. And then sum all the digits. It's 42. Since 42 is not a multiple of 10, the number is invalid. This lab would build a credit card validator using the Luhn algorithm. Objective: fulfill the user stories below and get the test to pass to complete the lab. Let's put one of our tests in here to start with. Should have a function named verify card number. And then we're going to have a number. We'll call it card number. Oh. All right. These tests are basically just checking to see if this thing is valid, and then we get to fill this in. So it's all caps. Total modulus 10 equals 0. Then we return valid. Else turn invalid. So that, now we have to arrive at the total. So let's back up a little bit. We got some of these have dashes in them, or this one has dashes and spaces. So you have to have a clean number equals I'm going to replace the dashes with nothing. You still have spaces. You can actually kind of recursively work on this. So let's see, replace. There we go. We clean that number. Let's put this other test in here just to make sure it's working. Yep. All right. So we have our clean number. Then digits, convert the string to list of integers. All right, we need to, we can't just, these are strings right now because that's how we cleaned it. So now we need to turn it into integers. But you can't just make strings an integer. What we have to do is, and we also want to work on these one at a time. So what we need to do is create a list of these. So digits list equals this list comprehension. So for digit, we're going to return the integer version of the digit for digit and clean. So there we go. Print this to see what it is. There we go. We got our list of integers now. So now we have our list of integers. We need to, we have this. So we cleaned, we got our digits, we got our total. And so what we're gonna do is we need to start at the end. Like for example here, and start here. Actually we're gonna start here, because in the example, yeah, the 1 is included. For some reason I was reading this and I was like, oh, we skipped the last digit, but we don't. So here, that would be 9, that would be 8. And so for every other one, let's see what we need to do. We need to go, we just need to add that to our total. We need to double that. Right to left. All right, doing a little research. So first we have the length of our list. And then in range. There we go. Let's start at our last digit. We're going to go backwards. Let's go print I for right now. So let's comment the second one out. Digits. So 16, that's correct. Okay. So 16, 15, 14, 13. And then we need to do every other one, which is oh, digits -1. Is there 16? And we're going to go 15, 14, 13, 12. All right. So going from right to left. And the digit that we're going to operate on is the item at that index. Should be able to print digit. And it gives us the number in reverse. Okay. And then if the length of digits. So you need to figure out if this is even or odd. -1 minus I modulo 2. Is this list even each time we go through? And so if it is even, then digit times equal 2. If the digit is over 9, then digit minus equal 9. And once we determine all that, we take the total and plus equal the digit. So everything's working. Let's see if we're passing any of our tests. Let's test. Oh, you know what? Simple. All right. That was our implement the Luhn algorithm. So that was interesting. I feel like we did something like that closer to the front where we, like an ISBN validator or something like that. Is it up here? A Caesar cipher. Oh, maybe that was something else. Anyway, there's that. You're on your own for the review and quiz, and next time we will do the implementation of the Tower of Hanoi algorithm. And I'll just be doing a code review on that. I'll solve it, and then I'll just run through the highlights and the things I ran into that I had an issue with. So thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you next time. Thanks.